No, we're recording. Okay, we're now doing exercise 3C, question 7, part F. Right, I have actually done this in class, but here I'll do it again in video form so you can rewind and look at it again. This one's a little bit trickier, and it uses trig identities, and this is a chance for me to go through that. The trig identities are not in your course explicitly, but it's possible you may have to use them. They would be provided to you if you did need to use them, so you don't have to memorize some of the identities that come up in this video. All right. Now, if you hear a gunshot going off in the background, that is because I live in the hills and some of my neighbors have vineyards, and I think what's happening is that they are trying to scare birds away while the fruit is on the vine. Okay, so I have taken the first derivative of this function. The function is f of x equals sine of 2x plus 2 cos x, and it makes a nice trigonometric graph that we will get to. This question is focusing on stationary points, maxes and mins, but we will end up graphing that and showing where the maxes and mins are. And to find stationary points, I need the first derivative, right? So derivative of sine equals cos. Remember, we've got like a little chain rule thing going on here. We've got an outside function, the sine, that goes to cos. And then the inside function, 2x, the derivative of that is 2. So don't forget that 2. Here, the derivative of cos is minus sine. Okay, that one's maybe a little bit easier. We find stationary points when the first derivative equals 0. I think if I had $1 for every time I said that, I'd have about $73.20. Okay, so when the first derivative equals 0, all of that's got to equal 0. And this has got to equal 0 here. So that I don't have to write out some working, I'm just going to say from the get-go here, cos of 2x, right? Let's just write a little when. The first derivative equals 0 when cos of 2x equals sine of x. Okay? So what's happened, I've taken that and added it to both sides. It's gone over there, swapped what it was doing. It was minus, now it's plus. And then I've divided by 2. 2 cancelled out to make this statement here. Okay, at this point in these questions, we want to have a unit circle. Right, so I'm drawing a unit circle, as you can tell. There's some vicious lies and dangerous rumours going around at your school that some of the teachers doing these videos are wearing pajamas. Well, I can assure you that in my videos you are getting quality. You are getting no pajamas. Right. Okay. Now, you guys should by now have memorized unit circle. Notice how when I do a little sketch of my unit circle, which I do a lot in these questions, find it very useful, I only bother most of the time to draw out the first quadrant. Okay, and that's because second quadrant, third, fourth, they're all just repeating those values, but with some negatives splashed around for good measure. Okay. Now we need to find by inspection. If we have some value x, some angle x in the circle, and then we sine it, right? We need to get the same answer as if we took that same value, doubled it, and then cosed it, right? Did the cosine. So for this question, I could go around point by point on the unit circle and test these out. The first one here, cos equals 1, sine equals 0, that's happening at an angle of 0. Now if I double 0, obviously that's not going to go anywhere for this equation here. But if I go to the next point, think of pi on 6. This little angle in here, it's pi on 6. And if I made my x pi on 6, the sine would equal a half, right? Then I go over to this part of the equation. Pi on 6 times 2 is 2 pi on 6. That's the same as pi on 3. What's cos of pi on 3? It's up here, right? That's pi on 3 angle, and the cos is a half, and I've found my first solution. And I could keep going round inspecting. I'd need to go around the whole circle, right? Equals pi on 6. Now because I've done this question before, I know that there's a solution down here, which might not be immediately obvious. It doesn't look anything like the pi on 6 I just found. So I'm saying that if we go all the way around here, 3 pi on 2, plug that into sine, and I get minus 1. Plug it into this part, cos of 2x. Okay, 2 times 3 pi on 2 is just 3 pi. Okay, 3 pi. So starting at 0, go around, there's pi, there's 2 pi, there's 3 pi. I'm over here now for my cos value. Minus 1, 0, and there's another solution, right? The cos was minus 1, or cos of 2x, and the sine of single x was minus 1. So that's another solution. That one didn't stand out to me initially, right? And there is actually a third solution. So we're going to now show you how you could find them algebraically. But the bad news is that we need trig identities for this. Okay, I'm going to make a bit of room here. All right. And I think I may also pause the video at this point so it doesn't get too long.